Okay, and I do want to give a nod to Steve McCabe, who is also with the experts team, and he's double booked, so he's actually speaking right now, so couldn't be here, but you can always hit him up for more info as well. But yeah, thanks to Renato for making the trek out here from the southeast, and it's certainly great to get the customer perspective and I guess you could say the FME or the SAFE perspective on how can we better support UAVs with FME. So yeah, a quick nod to Southern Company, clearly a very large power company in the US from both the southwest to the southeast and even up in the northeast. So a lot of customers and a lot of facilities to manage, maintain, and survey. So what we're going to talk about today, I would have waited a minute or two competing with a hackathon, but we got a lot of material to cover, as you can see, so we'll just roll through it. We're going to look at some of the unique challenges posed by UAVs, as well as what are the opportunities and how FME can support, focusing on the mission life cycle, we'll see in a sec. And then we've got a number of interesting use cases and some looking forward to next steps. So when we're talking about UAVs, that's unmanned aerial vehicles. Renato's team, they call it unmanned aerial systems, or the more generic consumer term, just drones. And there's the Mavic, and I think there's Steve's initial idea for throw your iPhone in the air, see what happens. So yeah, there's lots of, that's the initial prototype, but it didn't work very well. So there's Steve's Mavic. That's kind of a nice compact platform, and Renato has one here as well. You can look at it afterwards. So what's the challenge? The opportunity is you've got these new platforms collecting tons of data. They're obviously very inexpensive and surprisingly accurate, good quality data that you can get from them. The challenge is that you've got this flood of new data to deal with. You've got both imagery and video, and then you have a lot of telemetry files that need to be parsed, and so it doesn't take long to get overwhelmed. Then there's the issue of safety and security. So clearly you've got, in Canada, we have Transport Canada regulations, in the US, FAA, and so you have to make sure that you're complying with all of those. And then there's just the safety, in the airspace itself. So in addition to all the regulations, it's the operator's responsibility to make sure that nothing bad happens. And so, yeah, there's safety and security around that, and the data processing and distribution. So the opportunity, clearly there's a big opportunity there, given the low cost of the nature of the platform. Instead of going out there every 3-6 months, you can fly something once a week or even every day if necessary. So the frequency of data collection, then you get into things like you can get into change detection and look at the types of analysis that may not have been viable before. And then going back to, besides cost effective and energy efficient, which is kind of obvious, again, back to the safety question, assuming you're complying with all the regs and you're not posing a danger to anyone by being in the air, you can actually perform a lot of activities that might be dangerous to actually put a person in the air. So if you're flying close to, like in Renato's case, power structures, or in potentially hazardous locations, putting a drone in there, you're not putting a person at risk. And ultimately, the goal at the bottom there is better awareness, better decisions. So being able to survey the environment in a more precise way and more timely. So in terms of how does FME come to play here, so here's a shot of Steve with his Mavic, one of the test flights. Clearly FME has a lot of areas where we can support UAV use. On the preparation side, so we'll see some examples of that. How do you prepare, 4 flights, 4 missions, doing the underlying data integration, visualizing the data, and automation and distribution. So there's all these aspects of FME. These are all things that FME is good at, and it also relates to the UAV challenge. So where I'm going to focus more on is on the actual UAV mission flow. So if you look at the planning, flying, and then post-mission, and then delivery of the results. So how can FME support each of those stages? Renato's going to get a little bit more into post-processing on some of the products, so I won't get into that right now. So in terms of planning, because clearly before you do something, planning's not a bad idea. You could just throw a drone up in the air, but you know, you could run into trouble doing it that way. So clearly what you want to do is first look at the regulations and the restrictions on airspace, airports, and make sure that your flight path doesn't violate any of that. Then the next thing we looked at was automating route generation with FME. And in this case, I just happened to come across this app called Litchi, which has a fairly, I was looking for sort of more complex XML or JSON schema, because that might make fun, you know, a cooler demo. You know, Don might like that. But it was just a CSV file, plain old CSV file, so that's fine too. That all works.
You got shapefile.
Yeah.
Shapefile,
yeah. And then some mission preview. Then we've got, for the actual flight itself, some semi-autonomous flight, I should really call it, because at any point we were in control range. And then review in KML. And Renato has some cool stuff we'll see later, more detail on the review side. So this is just AXM data. So that's something that FME supported for a long time, airspace data, whether it's 4.5 or 5.1. In this case, I actually was reading 4.5. And we're buffering the airports by the 9 kilometers and then by a certain height. And then there's smaller aerodromes for things like heliports and whatnot. And then you can see there, I think I'm clicking on Abbotsford. So the YXX in the Eastern Valley, YVR is on the west. So you can see a lot of the airspace in the lower mainland is restricted. But being able to visualize that, we found Google Earth is a good platform because you can spin it around, you can look at it in 3D, you could import your flight plan into Google Earth and see if any of those things intersect. So one of the things I do when I'm not at SAFE, I volunteer with RCM SAR, so that's Royal Canadian Marine Search and Rescue. It's predominantly a volunteer organization, so even though we operate under the Coast Guard mandate, it's a volunteer organization. And so we do search and rescue. And one of the things we looked at, SAR, you can kind of see from here, I'll let this video play, is that particularly in the Mud Bay area, we have a lot of shallow water where boats can't go and the land-based responders can't go. So typically, like, our boat will only do 1 meter, can't go shallower than that. And then if a police, ambulance, fire is responding on land, they're not going to go into those mud flats. So being able to survey a large area in a short period of time, if we get a drop 911 call, it's a lot quicker for us to be able to actually locate where an individual is, and then we can direct the right resource there. Otherwise, we're going to sit around, wait 45 minutes for the hovercraft to come from YVR. They're the only ones who can go in the mud flats, and then that ties up the hovercraft in case something else happens in Vancouver. So this is just, it's not used operationally yet. We're just evaluating different platforms, but that's the goal, to be able to use the UAVs for search and rescue. All right. And of course, some of my colleagues at SAR, are we going to be out of a job? No, of course we're still going to be, just going to get back, yeah. You need the responders, but this just helps you find, the individuals more quickly, and of course, time is money. Being able to more quickly respond and locate, then you can get the right resources and recover them faster. Okay, so what are we actually doing in FME in this case? Basically, there's some user inputs that are used to generate the search pattern, and we want to automate this as much as possible. That's what FME is good at. So you don't have to have somebody manually populating that spreadsheet to figure out where the waypoints are and doing the math, because that's all. Anytime you have a manual process, it's prone to human error. So there's some search parameters about the actual location, the starting point of the search, and the leg length, and the type of search pattern. Then the workspace georeferences that, generates the waypoints, and then basically builds that CSV file according to the API, in this case, Litchi API. So that's the parent workspace. It's fairly simple. It's just a custom transformer which generates the waypoints and then maps that to the Litchi schema on the right. And then underneath that, I won't go through all of this. This is basically where I'm creating a leg of the geometry, and then based on the user inputs, I either make a sector grid or parallel grid. And then what it does is it puts in commands at each point. You can tell it how long you want it to stop and what you want to do at that waypoint. In this case, take a picture. So there's the actual parameters, leg length 120, lat long, elevation that you want to fly that at. And there are the instructions. We preview that first in Data Inspector. Then this is the Litchi app online, which is like a, it's basically a web app, cloud hosted. And then you can import that CSV file that lays in the search grid. So it gives you another level of preview. You can make sure everything's okay, inspect those points. And then for the photo survey, I chose this parallel grid. And then you can preview that. And then it basically just goes up, flies the whole thing autonomously. It takes about 7 minutes in this case to cover that about 1/3 square kilometer. And then post-mission, we get the SD card, stick in the computer, and then run a workspace. And what it does is it reads the JPEGs, extracts the lat long, converts to decimal degrees, and then it georeferences the images and writes out KML. So this is the workspace. All it really does is, parses out the lat longs and calls the raster georeferencer and sets the coordinate system. And so here you can see that those mud flats in Mud Bay, and you can pay attention to that central sandbar there, and you can see that it overlays fairly well. And if you zoom in, you can see it's accurate to 1 to 2 meters, which is close enough for SAR applications. It's not meant to be for survey grade. It's can you locate an individual or a boat? So that's basically the idea. Then there's a nod to the SAR unit that I'm part of. That was an exercise 2 weeks ago that we participated in. And that was Okay, so just before I pass over to Renato, just a quick review of that, the UAV mission workflow. So good planning reduces risk and increases your compliance. Realistic preview is key, so there's a number of tools that can be used to preview the mission. I think automation on the waypoint generation, that means you can more rapidly respond. In the search and rescue environment, time is lives, it's not just money. So if you can more rapidly get resources out there, so much the better. Again, autonomous flight missions, it reduces human error, means you can have a drone, fly a mission, get the data back, swap the battery, swap the chip, fly another mission. So you can keep things moving quite quickly. And then ultimately, if we can review that data, post it up online or post it in the cloud, then there are analysts that can review those images. And again, you're not leaving that to somebody who's flying the drone to peer into their cell phone to see if they can spot somebody. That's happening by a number of people over the web. Okay, so over to you, Renato.
Thanks, Dean. This is the overview of what I'm going to be presenting today. These are some of the advantages. Dean has mentioned safety, cost, less impact to the environment. But I just want to highlight that a big factor for Alabama Power and Southern Company fly drones was 4 years ago. We had a helicopter crew crash in our area, and that was really an eye-opener for us to determine whether it's possible to fly drones in some of our missions. So these are some of our activities. Assessing storm damage. We have determined that sending drone teams together with ground teams during storm restoration is valuable. Local storm coordinators must be able to pre-identify right-of-way corridors that are fly or no-fly zones, so that way we can optimize. We could be optimally using our resources properly. Using GIS data, maps, and local knowledge of areas in where storms have hit, then we could use drones more effectively. And we have established best practices for these. This is I-85 Atlanta, downtown. We have a bridge collapse. It was assessing damage due to human carelessness is a good application for drones too. The fire that collapsed this bridge is a man burning a grocery shopping cart, which basically snowballed into a bigger fire. So, and it just collapsed. So we have a transmission line, as you can see, and it was necessary for us to inspect that particular transmission line. Of course, a very popular application for UAV, photo and video. You can see there's a second drone on top of that stack. This was done a few days before the rehearsal, or it was a rehearsal before a implosion of that particular stack. It was significant because this was the first time Southern Company has flown 1,000 feet above ground level. Of course, with the additional 400 feet maximum height, so that's basically about more than 1,000 feet. Cold bunker inspection, a new application that we have for our generation. You see the pilot on the lower right is the video of a pilot with this GoPro, and he's standing on a platform in between the tower, and he's using the drone to inspect for internal damage or corrosion within the insides of the particular bunker. He is flying a Phantom 3 with no GPS inside that bunker. You'd notice that how important that light payload is there's only, it's not easy to put just any non-standardized payloads on a drone, because otherwise you may lose that, the safety, or there's possibility that you can crash. So that payload light, as you can tell from that picture, is very important. All right, we have a lot more, but I'll just move on to our UAS workflows. We've been testing also some FLIR, or infrared imagery as well. So our program started with our R&D department. It's been with R&D for about 20 months. We spun off from an innovation contest and the concern for human safety. We started off with Section 333 exemption, almost 100 missions flown, more than 1,000 flights, and about maybe around 5 to 7 pilots that were under that exemption. We also tested more than 20 applications, and many missions were flown from our training facility at Klondike, Georgia. And there were tremendous amounts of lessons learned in those 20 months and we partnered with a lot of vendors, as well as folks as well as utilities who've been into the UAS space. On the pictures is our research engineer who managed that UAV program, and our first aircraft, which is Aerion Sky Ranger, which is manufactured here or designed here in Canada. We're actually going to retire those Sky Rangers because they are so expensive. They're military specs. So 12 months into R&D, our pilots were drowning in data, so they walked over to me and said, hey, what can we do? They've accumulated that much data in 12 months, so this is their workflow. They fly their drone, collect the data. The drones wirelessly send back the data into our network. No, I'm just kidding. There's no magic there. Someone has to pull out the memory card, get back to the office, and store all the data in the network folders. And then the pilot maintains a spreadsheet of all the missions. And then from every month, he will call some of the other pilots and, hey, give me your mission information. So that was my first challenge. How are we going to index and catalog all this data? So every aircraft has different cameras, have different gimbals, which means there's different ways of collecting that metadata. The most popular ones that I've found in a lot, at least in our aircrafts, were the native JPEG EXIF, and then you got NFO data, which is basically an info text file that was post-processed with the Aerion or Sky Ranger. So you can tell that EXIF has GPS, and NFO data has also the camera and GPS, as well as telemetry data of that gimbal. So with that telemetry data, I'll be able to determine through some math which of these pictures have been collected for nadir or oblique, which means I would be able to put some translation into some logic into my translation to determine which pictures are for surveying or for inspections. So I developed an FME workspace, and these are the output. I created a mission data catalog in Excel. Every picture and every folder and every project has a link in this spreadsheet. And then you can notice at the bottom, there are tabs for different kind of purposes, and this was generated all by FME. I even have a tag there for ground photos and videos. Of course, that was possible with the right proper directory structure. Sometimes I have to massage the data a little bit, so, but it is generated by FME. So this is the feature service, same workspace, directly into S3's portal. You can see from the feature service there are 3 layers, one for each picture, waypoints, which came from the telemetry data created, which was taken from the info file, and then the flight path, which is basically just point to point from each waypoint. On the picture point feature and the flight path feature are feature attachments of the actual, well, for flight path, it's the report or the catalog, or for pictures, it's the actual picture. So they are feature attachment from within that feature service that's stored in the portal, and they've also been generated by FME through some, I guess, the metadata. So I was tying the metadata with the actual picture name. So March of this year, we are operational. The program has been transferred from R&D to our internal system air organization, so they're now responsible for it. We're operating under Part 107, that's the FFA rules that came out last year, our own operating manual, as well as more waivers. Our system air is responsible for compliance, safety, trainings, and standards, and we have trained almost 40 certified pilots today. It's probably going to be 70 at the end of this year. My own organization, the distribution organ, some of our pilots have this kind of, this Mavic, and with this small bag, it can fly up to almost 1 hour, but we typically cut that down to 60%. So there'll probably be a 45-minute flight for every pilot that we have who's going to be carrying this in his truck. We've also standardized our aircrafts for fixed wing, hexacopters, and quadcopters. Most of them are DJIs and the SenseFly EB. So here are my data challenges for the current, and a couple of them that I'm going to show where I've used FME. I've improved the mission workflow, no more spreadsheets. I developed created a survey 123 from S3 survey, so to fill up their data or their mission as well as their job JSB checklist. They're still copying the data, no magic yet. Maybe SAFE can help us in the future sometime. Maybe, Dean, what do you think? Sure. And then the mission status is, once the status has been changed on the survey form, it triggers at a scheduled task an FME desktop workspace that looks at the folder if there's new data, as well as check for the status. Once FME finds that those two are present, then it goes through the same process as the previous workspace, but this time it's doing it for every mission on a operational basis. So there's no more Excel again. I've converted the writer from Excel to HTML, same features. So now every mission is, a web map is created. The GIS analyst still has to create a web map within the portal, but all you need to do is just open that feature layer and open the feature layer, save the map, and share the map to the group users. All right. So I also created a dashboard. Every mission that's been updated the information gets updated into workspace as well, or the dashboard. So this is the flight planning, next challenge. We got same logic same use case that Dean had, but this time using our own feeder data. Some notes on data. We have accurate pole locations, which could be good use for POIs, but it has no elevation. Our transmission has as-built data, so this is survey-grade data. Lastly, our transmission and feeder lines are offset from poles by design. So data quality is important. So with a few KML transformers, and I just built a workspace and developed this application, this flight path that is going to be used for viewing. So I'm just going to run this Google Earth KML.
So here's a little movie that was made, and I guess this is based on the CAD data ultimately?
GIS data.
GIS, okay.
You got 4 waypoints. It's like starting off from the center of the pole. Then you got a certain diameter or distance from each pole. I've you can see that the poles are extruding behind the safety net. The actual pole, top of the pole is the yellow halo. So this is really, well, what we learned yesterday, the other day was visualizing failures. At least then pilots would know that they should not be flying this particular UAS flight. So I'm just trying to highlight that.
Yeah.
All right.
Yeah, so that's a great way to preview things, and that would, you know, if the flight did actually go too far and run into that wall, you'd be able to catch that on the preview.
And it'll also run through the football stadium. We don't have any ghost drones yet, but
Yeah.
the idea there is, you know, you should not fly this particular flight path. Come back to your workflow and change the parameter so you can eventually send it to.
Okay, well, we're out of time, so I'll just quickly wrap up. Yeah, I guess there's some more stuff that you guys might get into in terms of autonomous missions. But quickly, just to wrap up, there's lots more that we could do in terms of what's next. There's more that can be done on the pre-flight planning, more of the regulations that we could model, for example. You could maybe have an online service where somebody could upload a mission and it could tell you, here are the airspaces that you might be you know, crossing into that you should look out for. There's tons of APIs out there that can be integrated with. There's Esri has, and other tools like Drone to Map from Esri, Drone Deploy, Open Drone, DJI, and then even the idea of cognitive services, where, you know, conceivably if you had a whole ton of imagery, let's say for SAR application, and you could analyze those automatically for, okay, these are just water and nothing else, then you could narrow down to, here's the 5–10% of the imagery that's actually interesting to look for that lost boat. But there's probably a bit of a learning curve there, because I noticed Soren had a presentation this morning with a forest fire, and it just said like trees or something. So
A lot of conversations has been going on around with either Microsoft, Esri, and Watson in that particular area.
yeah. So again, sorry we're out of time, but just quickly to summarize, you know, FME, I think there's a lot of ways that FME can support UAV activities to promote safety, both in terms of compliance as well as using the platform, so we don't actually have to have manned flight in many cases. Also allowing the operators to focus on their mission, not wrestling with data, and all aspects of that mission life cycle, plan, fly, review, delivery. There's aspects that FME can support there. So ultimately, automation is key given the data volumes, and we want to be able to you know, summarize, process that data, and distribute it ultimately so that decision makers are supported and can do their job more quickly. So thanks, and I've got to talk right now, and I know Renato has to take off, so you can probably catch us. I'll be at the ice cream time around the doctor's office, or you can just send us a line.
Thank you very much, Steve.
Yeah.
And Renato.